All right. I'd like to try to provide some clarity. There's been some number of questions about the nutrients application setbacks and recognizing that they go into effect January 1 as part of the nutrient management program. We wanted to include a segment today to clarify how these application setbacks apply. Spend a little bit of time talking about the definition between a stream and a ditch, and we're going to make that so crystal clear it'll shine. We're going to talk a little bit about measuring the setbacks, 10 feet from where, and then there's also an element of these application setback that considers alternative BMPs in pasture settings, specifically to pastures and livestock. And then finally, there's a presentation to follow that's going to expand on what Trish mentioned in terms of a tool or a method by which we can map this out in the planning process and provide a little more documentation. So to begin, while I'm sure everyone understands the distinctions between perennial and an intermittent and an ephemeral stream, I'm going to refer to them. So somebody said, keep me awake. Where's the video? I got to have something to keep me awake here. So no video, but we're going to start with this definition. So to be clear, when I say a perennial stream, I'm talking about a water course that contains water all the time, and generally it's influenced primarily by groundwater flow. When I refer to an intermittent water course, whether that be a stream or a ditch, that flow or water is more seasonal in nature, and it can be influenced either by groundwater as groundwater levels rise seasonally or based on surface runoff. And then finally, an ephemeral stream or water course is one that contains water or flows only as a result of precipitation. So I think those are probably the easiest to understand and define. So, where do the setbacks apply? I'm going to make a distinction. I'm going to refer broadly to water courses, and then I'm going to try to narrow that down into two categories, either streams or ditches. And once we get to stream or ditch understanding, then we'll apply perennial or intermittent and ephemeral, and as I say, it'll be so clear you'll just simply be amazed. So, in a natural, I'm going to call the stream as a natural water course. So, where you have a natural, perennial stream water course, or an intermittent natural stream, the setbacks apply. If you have an ephemeral natural stream, the setbacks don't apply. And in fact, if you have an ephemeral ditch, something that a water lead or something that you cut across the field, then to be clear, the setbacks do not apply there. And generally, when we get to this definition of ditches, the setbacks do not apply to ditches. So then it begs the question, how do we define a stream from a ditch? Generally, with a little bit of a narrative explanation, but we're going to get into a table and a sort of a flowchart type approach that I think makes it more clear. Streams are naturally occurring. They're generally sort of sinuous or winding in nature. They're generally accompanied by certain biotic or vegetative species that occur naturally along this water course. As we refer to them and we'll define them, the ditch is going to be man-made. They're generally straight. Whether it's a drainage attached ditch kind of network on the lower eastern shore or more of a field ditch location or configuration elsewhere in the state. This table is adapted from our Maryland Conservation Reserve Enhancement Program. And in that, when we first developed that program, we had to delineate or determine what was a stream and thereby eligible for CREP practices from a ditch, which were generally not eligible. And so while the table looks familiar, the purpose of this table here is to just sort of walk through this discussion and use it as a format to determine what's a stream versus what's a ditch, and thereby define or understand where these nutrient application setbacks apply. So, top block up here. We're going to refer to the water course, how it's defined, and then whether or not the setbacks apply. So to step through it, just as I said, where you have this natural water course and it's either perennial or intermittent, we're going to define that as a stream. And because it's defined as a stream, the setbacks apply. Now, we're going to get into what I'll refer to as a channelized watercourse, which are these constructed drainages. And to be clear, where that watercourse is channelized and the flow is perennial, and that watercourse either lies within a floodplain soil map unit or it lies within a hydric soil map unit that's mapped in a long fluvial or stream-like position, floodplain position. Or thirdly, it lies within a B slope or greater, then that watercourse is defined as a stream and the setbacks apply. So step back through, and then let me finish through it. If it's a channelized / parens man-made watercourse, the flow is intermittent. Channelized and intermittent, that's a ditch. And setbacks do not apply. And as I said earlier, where it's ephemeral, where you have flow just as a result of precipitation, whether it's natural or channelized, it's a ditch and do not apply. So, simply said, natural, perennial, and intermittent streams, and then the channelized ditches that are perennial and they lie within a floodplain soil mapping unit or a hydric soil map unit in an elongated position. I'll show some sketches. Or you're in a B slope. Those are the situations where a constructed / channelized / man-made watercourse are defined as a stream and the setbacks apply. So, a couple of examples. This square on the left side of this slide represents a field. And this irregular shaped thing here in the middle is a soil map unit, and I've labeled it soil A. And this line that I've drawn across there is a watercourse, and because it's a straight line as you see, we're going to interpret that as a channelized or constructed drainage. So, referring back to the table we just used, the watercourse is constructed drainage. The soil A is not hydric, and in this case then, the setback requirements do not apply. This watercourse would be defined as a ditch. A different example, where you have this soil down here in the dark color that I've labeled as soil C, oh, come on, is hydric. The watercourse is constructed drainage, the flow is perennial, and this soil C presents itself in this elongated position, this fashion, and by policy we've interpreted to say that it's over half of its length, over half the length of the stream within the field, is this hydric soil in this elongated fashion. It's defined as a stream, and the setbacks would apply. There is a table that I had hoped to have produced as a handout. So was that on the table when you walked in? Good. Okay, so you have a copy of that table, and the rest of this presentation, as Tricia said, is going to be posted and available. And further, we've got a guidance document that will be appearing on MDA's website, which puts a lot of this in more narrative form, but includes these examples as well. So in this final example, you have a watercourse that appears as more natural. It has this winding nature to it. Just to confuse you, I've said that soil C is hydric, and in this case, the setbacks apply. It applies not without regard to why it's hydric. It applies because that watercourse is natural and it's intermittent. So it's a natural stream, it's intermittent, and the setbacks apply. Seems clear to me. Wanted to spend a minute to talk about how to measure these nutrient application setbacks. So this sketch shows what I'll call a stream bed, which begins here and ends, well, let's do the top of the water course. And in the bottom of this will be where the water actually flows. So recognizing that in certain stream beds, whether it's a constructed drainage system or a natural stream, you'll have this meandering nature that shifts over time. But what we want to do is begin measuring at that edge of that water, what I'll call that water course. Begin our setback measurement from that point, not the top of the bank, not the edge of the field, but rather what I'll call the edge of the water course. So within this first 10 feet, back from that edge of that water course, measured horizontally, there's no nutrient application. And then, as provided by the regulation, in the area between the 10-foot mark and the 35-foot mark, there can be a directed nutrient application. And then beyond the 35 feet mark, when you're applying nutrients in a broadcast fashion as would apply. So, to provide a couple of examples, these broadcast applications that are 35 feet and beyond are clearly the spinner spreaders. I included dragline applications. That might be subject to a little bit more interpretation, but clearly these high volume horizontal nozzles that are just broadcasting material broadly versus a more specific directed application where you'd have a vertical fan nozzle attached to a boom, obviously a knifed or injected application, something like a drop nozzle off of a boom applying liquid product, or anything that's being applied through a coulter or an injector, again, such as a planter application or starter fertilizer. A couple of applications just to clarify. The regulation said in a pasture situation, as an alternative to fencing, that there could be the opportunity for the Soil Conservation District to do a site-specific evaluation and assess that site for alternative BMPs that might be appropriate and sufficient to protect water quality and stream health, rather than this what's been interpreted as a default requirement for fencing. So obviously, I think that this will be site by site, and we're going to be relying on the technical expertise that's long been provided through the Soil Conservation Districts to provide that type of evaluation. In many cases, there may not be an alternative, and the fencing, is going to be necessary to exclude the animal from that 10-foot zone. But to the extent that the Soil Conservation District comes out and evaluates certain features or site-specific characteristics, and I've listed here a few, whether it's the slope or the soil type in that particular setting. Animal density, I think, can be a consideration. There can be a sort of an observation and assessment of how this water course makes its way through the pasture, and in fact, the actual distance between the edge of this pasture and the water course is obviously a consideration. But are there natural barriers I've referred to? I mean, there may be certain vegetation that by its nature excludes the animal from that 10-foot zone and can be affected. There could be a change in elevation, whether it's a bluff or a steep slope, that the animal's just naturally not going to attempt to traverse and get into that 10-foot zone. Or other existing BMPs, whether they're alternative watering facilities, sort of heavy use areas, these pasture management technologies, rotational grazing, for example, that might be an option for alternatives to fencing. We're working with the Soil Conservation District now. What we envision is having a certification form that would be included as part of the planning process, and it would identify this farm and this pasture, and there would be a sign-off by the Conservation District that the specific BMPs listed or the management that was being applied to that was a sufficient alternative to meet the intent of the regulation. So that is forthcoming, and then again, you'll find that also posted on the MDA website under the nutrient management section as a tool for plan development. So if we can bring the lights up, those were the three issues that I wanted to highlight to try to clarify some of the questions that we've been hearing about nutrient application setbacks. So, questions? Told you it'd be crystal clear. Our next presentation, Mike Stanton from MDA is going to come up, and he has a demonstration of some tools, some mapping tools that I think will be helpful as you're writing plans and documenting these setback areas. I've got a couple commercial announcements, but I think I'm probably going to hold them till the end. So, Mike?